Uh, Hi guys, today I'm going to explain experiment 5 statistical inference from the data science ecosystem lab. In this experiment, I am using a supermarket dataset and applying the different statistical methods. First, we find the sample mean, population mean. Then we calculate 95% and 99% of confidence intervals. After that, we find the relationship between the variables using Pearson and Spearman correlation. We also calculate the covariance and create a correlation heat map. Finally, I perform a Z-test to check given claim using the sample data. This experiment helps us to understand how the statistics can be used to analyze the data and make the decisions. Now I'll explain each question one by one. First, I have imported the data set. Next, first question is sample mean for unit price and n equal to 500. The aim of this question is to calculate the sample mean of unit price. We are using the supermarket dataset. From the dataset, we are taking only the female customers. From those female customers, we randomly select the 500 unit price values. Then we calculate the average of those 500 values. This average is called as the sample mean. First, let me know what the sample is. The sample means taking a smaller number of records from the larger dataset. For example, suppose a college has 5,000 students. If I select 500 students for analysis, those 500 students are called as sample. Similarly, how we have many customer records, but we select only 500 records. So 500 is our sample size. The column we are using is unit price. Unit price means the price of one unit of a product. We are interested in finding the average unit price for our selected sample. First, here I import the pandas. Pandas is a Python library used for handling the data sets. It helps us to read CSV files, filtering the data and calculate the means. Uh, uh, Here I read the CSV file. This dataset is stored in the variable called df. Df represents our complete dataset. Next, for filtering the female customers, here I filtered the dataset. I'm telling Python that I only want rows from the gender is female, so that after this line the variable female contains only female customer needs. Next, selecting 500 values. This is the most important line. Um, First, I select the unit price column, then I randomly select 500 values. If n equal to 500 means I need 500 values. Random underscore state equal to 1, which is used so that same random sample can be obtained again when we run the program. Next, we are calculating the mean. Now Python calculates average of the 500 unit price values. This is average of our sample mean. We can think of the formula sample mean equal to total of all values divided by number of values. Um, it is very useful because it may not always be practical to analyze every single record. Next, second question. Hmm, it is to calculate the sample size. It is almost similar to the question one, but the main difference is the sample size. In first question, we calculate 500 values, but here we are going to select 1000 values. The purpose is to understand what happens when the size of the sample size increases. Sample size simply means the number of observations we select. Here the sample size is 1000. The large sample means we are using more information from the data set. For this again we are selecting only the female customers. Then we select the 1000 unit price values. The important changes from question 1 is n equal to 1000. This calculates the average of the 1000 values. Why we use 1000 instead of 500 is to understand the effect of sample size. Generally, when we increase the sample size, our estimate become more stable. A small sample may not represent the complete population very well. A large sample usually gives us more information about the population. A simple example, suppose I want to know the average height of the students in the college. If I ask only 10 students, the result may not represent the entire college. If I ask 100 students, it get more information. But if I ask 1,000 students, it get even more information. So increasing the sample size generally improves the reliability of the estimate. Law of large numbers. This question is connected with this law. In simple words, this law says that when sample size becomes larger, the sample result tends to be closer to the actual population value. Next, third question. Um, in the previous two questions, we calculated the sample mean, but in this question, we calculate the population mean. This helps us to compare our sample results with the actual population result. Actually, population means the complete set of data that we are considering. In our question, first we select the female customers, then we use we use all the available female customer unit price values to calculate the population mean. This filters the dataset and select the female customers. This calculates average unit price of all selected female records. Since we are using all the available records in this group, we are call it as the population mean. Difference between the sample and population is difference is very simple. Sample means used only some records. Population means uses all records in population we are considering. For example, imagine we are considering 1,000 students. If I select 100 students and calculate their average mark, that is sample mean. If I calculate average mark of all 1,000 students, then it is called as population mean. Why we need population mean? Because it gives a reference value. Next, fourth question. This question introduces an important concept called confidence interval. We take sample of 500 unit price values and calculate 95% confidence interval. Confidence interval is simply a range of values that we use to estimate the population mean. Instead of giving only one value, we give a lower value and an upper value. For example, suppose my confidence interval is from 20 to 25. Instead of saying the population mean is exactly 22, I am giving a range from 20 to 25. Where pandas is used for data handling and numpy is used for mathematical calculation and sci-fi provides a statistical functions. Again, we select the female customers, then we select 500 unit price sales. Here we calculate the sample mean, sample standard deviation, and sample size. Z value, since we are using 95% confidence interval, Z value is approximately 1.96. Then this margin equal to, this time calculates the margin of the error and the formula is lower equal to mean minus margin, upper equal to mean plus margin. These two values gives our confidence interval. Checking the population mean, this code also calculates the population mean. Then it checks whether the population mean lies between the lower and the upper limits. For example, suppose our sample mean is 50 and margin is 2, then the confidence interval is 48 to 52. So the 48 is the lower limit and 52 is the upper limit. Next, fifth question is to calculate the 99% confidence interval instead of 95%. Here we want to see what happens to the confidence interval when increase of the confidence. Same sample, we still use 500 observations, we still use the unit price column and also the female customer records. For 19% confidence interval, the Z value is approximately 2.576. Compared the question for confidence level is 95%, so the Z value is 1.96. Here the confidence level is 99%, so Z value is 2.576. Since 2.576 is larger than the 1.96, the margin of error becomes larger. Therefore, the confidence interval becomes then wider. Suppose the sample mean is 50, 95% confidence is 48 to 52. And at 99 confidence, the interval may be something like 47 to 53. The second interval is wider. Why wider? Higher confidence means we want to be more certain that true population mean is included. To achieve this higher confidence, we need a wider range. 95% equal to narrower interval, 99% is wider interval. Next question 6. It is to calculating a confidence intervals repeatedly. We calculate the confidence intervals for 25 different trials. Each trial uses 500 observation, 95% confidence level. Why 25 trials? Because if we calculate only one confidence interval, we see only one result. But if we repeat the process 25 times, we can understand how confidence intervals changes from sample to sample. These lower values is equal to square bracket and upper values is equal to square bracket. This tool stores the lower and upper limits of the intervals. And this for loop runs 25 times. Each time represents one trial. For every trial, we select a different sample of 500 values. Then we calculate the mean and standard deviation. Then we calculate the margin using the 95% confidence value of 1.96. And we calculate upper and lower limit. With the graph, after calculating 25 intervals, we plot them using a matplotlib. The x-axis shows the trial number and y-axis shows the unit price. Each vertical line represents one confidence interval. Why should we observe? These intervals are not exactly the same. This is because every trail uses a different sample. So the sample mean changes slightly and lower and upper limit can also changes. Uh, Question 7 is to calculate the Pearson's Question 7 is to calculate the Pearson's correlation. Now I'm going to explain question 7. Correlations tells us whether two variables are related to each other. Here we have two variables, hand measurements and height. These are the values given in this question. This imports a Pearson's correlation function from sci-fi.stats import Pearson R. Then this calculates the Pearson correlation coefficient. Pearson correlation value ranges from -1 to +7. If the value is close to +1, this is a strong positive relationship. It is close to -1, then it's strong negative relationship. It is close to 0, there is a little or no linear relationship. For this data, the value is approximately 0.7213. The value is positive, so it is very close to the +1. Next, eighth question is to calculate the Spearman correlation instead of Pearson. Pearson mainly measures a linear relationship, but Spearman works with the rank of the values and measuring a monotonic relationship. Here we have imported the Spearman function, and this calculates the Spearman correlation coefficient. For this given data, it is approximately 0.669. Here we have used a concept called rank, which simply means the position of the value. For example, if we have the values 10, 20, and 30, their ranks are 1, 2, 3. Why we use ranks is sometimes the exact numerical difference between values is not important as their order. In such cases, rank-based correlations is useful. Where the Pearson uses the actual numerical values and Spearman converts the value into the ranks. Next, ninth question is to about a covariance, correlation, and heat map visualizations. Here we analyze several numerical variables from the supermarket dataset. Covariance, first covariance tells us how the two variables changes the two together. If both variables generally increases together, then the covariance is positive. If one decreases and another one increases, then the covariances can be negative. Next, matrix is simply a table of values. Here each row and column represents a variable. Each cell shows the covariance between the two variables. Differences like covariance tells us the direction of how variables changes together, but covariance depends on the units. Correlation standardized between -1 and +1, so it is easier to compare. Here we use Seaborn to create a heat map. Heat map represents the numbers visually. Why does a heat map show each row and column represents a variable? Each box shows the correlation between two variables. The number inside the box is the correlation value. Heat map, here we are using this concept, which makes the relationships easier to identify the visually. Next, 10th question is to about this, to calculate the Z test. Is about hypothesis testing using this concept. Here we have a real world example involving a special high protein grain and weight grain of steels. Given information like average weight gain is 5 pounds, the population standard deviation is 7.1. We take a sample of 29 steels. The sample average weight gain is 6.7 pounds. We need to check whether the special grain really increased the weight gain. Hypothesis testing is used here to make the decision using the sample data. We start with an assumption called a null hypothesis. Then we use sample data to decide whether there is enough evidence to reject that assumption. Whether null hypothesis is H not equal to mu less than equal to 5. This means average weight gain is not greater than 5 pounds. Alternative hypothesis is greater than 5, which average weight gain is greater than 5 pounds. Next, here we are using Z test because the population standard deviation is known and it is given as 7.1. Next, the formula is Z equal to sample mean minus population mean. divided by population standard deviation by root of sample size. Therefore, at 5% significance level, we do not have sufficient evidence to support that the claim that this special high protein gain significantly increase the weight gain. Mm. Finally, this experiment helps me to understand how statistics can be used to analyze the data and make the decisions. Thank you.